Hello everyone, welcome to today's session on the human eye and the colorful world. So in this, we look at what is atmospheric refraction and also what is the scattering of light. So we learned about refraction, refraction through the glass slab, refraction through the prism, and how that white light gets dispersed into different colors like a spectrum, right? Now, let's look at what is atmospheric refraction, right? So between sun and earth, we have atmosphere in between, right? So what happens when the light ray travels through the atmosphere? So the atmospheric refraction is the bending of the light as it passes through the layers of Earth's atmosphere, because the atmosphere has different layers, right? Due to the variation in air density and the refractive index. So if you look at the diagram here, so the refractive index increases as we come closer to the Earth, because the air will be denser at the top, right? As we move close to the Earth, as we come near to the Earth, the air gets hotter because of the radiation, right? Or because of the reflection of sunlight from the Earth's surface into the atmosphere. So thus, the air towards the surface of the Earth is less denser compared to the uh, when we go high in the altitude from the Earth's surface, the air becomes more and more denser, and it is also cooler. So the refractive index is it will increase as we come close to the Earth in the atmosphere. Then the light ray, for example, a star. Let's say this is a sun, right? So when the light ray travels, we will see it as a straight line, but this is how it travels. It's bending and traveling. So that's why whatever we see in the sky, that is the apparent star position. It's not the actual star position, because the light ray bends and travels. Okay, so that is called atmospheric refraction. So what is atmospheric refraction? The bending of the light when it passes through the different layers of the atmosphere, right? Because we have air with varied density, right? Cooler air, hotter air. Cooler air is more denser than the hotter air, right? And the refractive index is also different at different layers of the atmosphere. So basically, the bending of the light while traveling through the different layers of the atmosphere, that is the atmospheric refraction. So why it happens, right? The atmosphere is made of different layers in the air. Then these layers have different temperatures and densities. As I said, the air that is closer to the Earth's surface, that is less denser because it is hotter, right? It has more temperature and less density. And as we go high in the altitude, the temperature reduces. It becomes cool air, which has more density, right? So light slows down when it enters to the denser air, right? So light slows down or bends as it moves from one layer to another. So the bending occurs towards the denser medium. That's the cooler air, right? So that's why whenever we see a star or a sun or any object in the sky that appears, whatever we think that it is appearing in a straight line, but that's the apparent position of it. But the actual position of it is in this the bend curve that we see here, right? This is because of the atmospheric refraction. All right. So what are the natural phenomena that we see because of the atmospheric refraction? For example, twinkling of stars, right? So we see the stars in the sky, right, in the night. So the starlight gets refracted multiple times as it passes through a turbulence of atmospheric layers, right? So we have different layers of the atmosphere. So it undergoes multiple times of, it undergoes multiple refractions, right? So that apparent position of the star changes slightly and rapidly it appears to twinkle. So as it is uh, as we see that light ray gets refracted multiple times, the apparent position that we see, it is like a twinkling. So stars are point sources of light, so even small shifts affect their visibility. You understood? So we can see that there is a shift from its original to the apparent position. So that's one phenomenon of atmospheric refraction. Now, let's look at the second one. That is, sun appears early and also sets late. So if we see the actual sunrise, we will see let's see here. Due to atmospheric refraction, what happens is we can see the sun about 2 minutes before its actual sunrise and also 2 minutes after actual sunset. So why? Because this is because the light from the sun is bent around the horizon. So when I say horizon, right, this is to see Earth is like a sphere, right? So for example, the observer is here, right? Here is the observer. So here is the observer. Sorry, guys. So here we have the observer, but to his, if we look at straight line, right? So this is the apparent position. But what is the horizon, right? For the Earth, his horizon is something here in a straight line. So this is because the light from the sun is bent around the horizon, right? So basically, light travels like this, like how we saw the stars. So light travels like this because of the atmospheric refraction. But how we feel it is like a straight line. So this is the apparent position, but this is the actual position. So that's why this deviation will take 2 minutes. So in that 2 minutes, what we will see is the we see the sunrise before 2 minutes, and the same case applies after the sunset. We still see the sunlight even after 2 minutes of actual sunset because of this horizon and the apparent position of the sun. Because if you see, Earth is a sphere, so what we see is like a tangent to the Earth, but the horizon is straight. So because of the real position and the apparent position, that difference we will feel it. So that is, we see the sun appears 2 minutes before the sunrise and 2 minutes after the sunset. Okay, so that's another phenomenon of atmospheric refraction. That's the bending of the light. Then wavering of objects over fire. So if you stand near to the fire, right? So the smoke or the fire is going. So at that time, if you see any object to the other side, you will see that that is like a shaky. It's going like a waves, right? So why we feel that? So objects viewed through the hot air. Hot air is what? Less denser, as we talked about before, right? So objects viewed through hot air. So I have some person standing the other side of the uh, fire. Now I am looking into that person through the hot air. So what is hot air? It has a lesser density. So it appears shimmering or displaced. So that person is like shaky or wavery. So why that happens is this is due to the uneven refraction because I have normal air, then hot air, and closer to the fire, it is more hotter. That means less denser. As we move away from the fire, the air again becomes colder and more denser. So there is a change in density. So the refraction happens multiple times, and that is uneven refraction because hot air, less hot air, less hot air, cold air. So that's why this uneven refraction will make you see that person or an object as wavery. So that is the phenomenon of atmospheric refraction. So You got it right. So what is atmospheric refraction, and what are the different phenomenons that we observe in our day-to-day life, right? Twinkling of the stars, and also sun appears to be before the sunrise, we can see the sun, and also after the sunset, we can feel that sunrise, right? So that is 2 minutes difference. All right, and also wavering of the objects over fire. Yeah, thank you. That's all for today's session, and hope you guys understood the topic. And in case you have any questions or concerns, you can contact me using my Urban Pro profile. Thank you, guys.